In section 8.2, we're going to explore the parabola. So that is, we're going to start with 8.2.1, which is the parabola with the vertex at the origin. So when I have something like with my vertex there, so it could go like that, or it could go like this, or it could go like this, or it could go like this. So 4 different ways a vertex with the parabola with the vertex at the origin could go. And we're going to work on finding the equation of that kind of parabola and understanding that a parabola is a set of all the points that are equidistant from a fixed point, which is the focus, and the directrix, which is a line. So if I have a point and a line, then the purple, the parabola, is the set of all the lines, or all the points, I should say, that are equidistant from those two things. So any point on the parabola is the same distance from the focus as it is from the directrix. That's kind of obvious right here at the vertex. You can see the focus is that far away and the directrix is exactly that same distance in the other direction. It's a little less obvious on other parts, but if you were to get out a piece of paper and draw a line and a point and measure the distance halfway between them and just look for ways that you get exactly that same, kind of play with your measurements and try to get that line to be equal to that line at any point on your parabola. And you can see this one's doesn't look like it's drawn to scale because those do not look the same distance. So, but if it was drawn to scale, then you would see that any point on the parabola is equidistant from the focus and the directrix. So more officially, our definition, a parabola is a set of all the points in a plane that are equidistant from a fixed line, that's the directrix, and the fixed point, that's the focus. The line through the focus and perpendicular to directrix, that is this line right here, that is my axis of symmetry. The vertex is at the tip, could be a max, a min, or it's at that's the vertex, and it's halfway between the focus and the directrix. So P is a variable right here that measures that distance between the focus and the vertex, or from the vertex to the directrix. I like to think of it as the P as the distance. It can be positive or negative, because if P is negative, then well, we're going to see down here in our equation that P can be negative, meaning that the parabola is flipped this way. So I like to think of P as the positive or negative distance from the vertex to the focus. So if I always start at the vertex to go to the focus, then I know it's positive going this way. And if I had a parabola like this, then I would know that P would be negative because it's going left. Just like the axes go from positive from left to right. Okay, so that brings us to the equation of a parabola. So you may be familiar with the form that we've seen before, which is y equals x squared. Or a parabola that's on its side would look like x equals y squared. Or a parabola that is facing down would be negative x squared. Or a parabola that's facing left would be x equals negative y squared. So this is the kind of familiar parent function. And today I want to show you the standard equation, which is here. So we start with the y squared equals 4px. The 4p tells us the width. So in this parent function, the p is 1/4. Okay, so our vertex for this section, we're just looking at the vertex being at the origin. So our focus is exactly p away from the origin. Going for, if your equation is a y squared, that means it's on its side, so our p is in the x direction. And if it's opening up or down, then it's y equals x squared, so then it's in the p is in the y direction. And the directrix is exactly opposite the vertex in that same distance. The axis of symmetry again goes through the vertex and the focus and perpendicular to the directrix. So there's my axis of symmetry. So if it's centered at the vertex, that means with my y squared equals 4px, it's going to be horizontal. It's going to be the x-axis. Whereas my other one, my x squared equals 4py, it's going to be vertical, or the y-axis. All right? So the directrix and the focus are guides. They define the parabola because it's defined by the distance. This is a set of points that is equidistant to the focus and the directrix. But they're not on the graph. So they are shown here for vocabulary's sake. But when you graph a parabola, you don't graph the focus and the directrix. That's more just about the definition of the parabola. Okay, so we talked about this new equation here, and we talked about how the parabola that is centered at the origin could go 4 different ways. It could be open up like this. That kind of looks a little too V shaped. I'm more of a U. Or it could be going down like this. Or it could be going to the right like this. Or it could be going left, open left like this. And you may already be familiar. This might be a review from Unit 4. This one, you might be familiar with that as your parent function and a negative x squared when it points down. When it points right, that means we have x equals y squared, so we're just exchanging the x and the y. And when it goes left, we have a negative. Well, today we're taking those parent functions and thinking about that standard conic section. So I want this form now. So our squared term comes first. So I'll switch the order. And the factor that's going to tell me how wide or thin it is that 4p, where p is the distance between the vertex and wherever the focus is, which again, we don't have to graph the focus, but it's a variable that will give us a factor that tells us how wide the parabola is going to be. Same idea over here, so I'm going to put the x squared over here, and I'll get negative 4py. And then for the x equals y squared, I'm just going to switch the order. So I start with the squared term, and my factor is a 4p. This time's a positive because we're opening right. And when we open left, it's going to be a negative. Actually, I should be more careful than that, because if you look here, it's always 4p. But here, x, I'm sorry, not that one. We decide if p is negative or positive. So p can be negative or positive. So I'll actually delete that little negative sign on both of those, because I didn't write it on the left anyway. But note that here p is greater than 0, so it faces up, opens up, and here p is less than 0, so it opens down. When p is greater than 0, with the y squared, it opens to the right, and when p is less than 0, it opens to the left. So if p is greater than 0, it's either up or right, and if p is less than 0, then it's either down or left, which makes sense. That follows the x and y axis signs. So for exercises 1 through 4, we're matching the parabola, and you can use those 4 pictures to think about how these equations match the graph. I also wanted you to share this picture with you, because I know in the online book it's kind of hard to see all 4 graphs at the same time. So I want to share this picture with you from a bound textbook. So looking at these, I'm just going to do number 2 since these are your homework and I want you to try these on your own. So let's look at number 2. So number 2 has y squared with the x. And so that's the parent function is y squared equals x. So that means it's on its side, so right? So it's a side-facing parabola. It's got the negative in front, so p must be negative. It looks like p is a -1. So if p is negative and it's side-facing, then that must mean it's opening to the left. So that would be A. All right, and then that brings us to part of the next section, 9 through 20. There are some others that go to the next section here, but 2 that you're going to be doing from that section that are the parabolas centered at the vertex are 9 and 11. So let's do number 10 for an example. So if I'm told that the vertex is at 0, 0, and the focus is at 2, so I like to get a picture of what that looks like so I can think about how it's facing. Which one of those 4 situations do I have between these four graphs? Which one do I have? So if my vertex is here at the origin, and the focus is at 2, 0, that's here, and I think of the parabola kind of hugs the focus. So the focus tells me how the direction of the parabola. So I know now the parabola is going to go in this direction. I don't know how wide it is yet, but I do know that it goes in that direction, so I know it opens right. So that means it's in the form of x equals y squared. That's the familiar parent form that I'm familiar. I don't know, so familiar. Familiar parent form. Again, this is not this function because I didn't consider the size, but that's the parent function that gives me the direction. And that tells me that my standard equation will be in this form. And then I know that P will be positive, and it's the distance from the vertex to the focus. So that going from left to right, that's 2 units. So P is a positive 2. Actually, so I'm going to write generally P is plus or minus the distance, depending if it's going left or right. It's going right, so I know P is a positive 2. So I can plug that back into my general equation here, and I get y squared equals 4. P is 2x, so y squared equals 8x. All right, so that wraps up that first section of 8.2, 8.2.1, where we have the vertex centered at the origin. So in the next video, we'll look at the vertex after it's been shifted away from the origin. So we'll come back to this section, both these sections actually, and look at some parabolas that are not centered at the origin.